All right, hey everybody. This is our our 2.2 notes covering topics in graphing linear equations. Before we get too deep into it, I'd like to introduce our guest host today, Autumn Kent. Uh, she is our first trans mathematician. Also, I believe our first mathematician that's still alive in the modern day. She's working out of University of Wisconsin, working on topology, geometry, crazy topics that I wouldn't even know how to broach. You can find videos of theirs on YouTube. Just give it a check sometime. Working on some really out there kind of stuff. The lesson for today with linear equations is going to have a little bit of vocab at the beginning, but then after that, we are going to really just switch it to practice problem after practice problem. The best way to do some of these kind of things is just to get a lot of problems behind you to build yourself up. So things that I would want you to do by the end of the lesson, you're going to want to locate the slope and intercept, and those are both vocab terms that we will introduce here in a little bit. And those are both from the slope-intercept form. So you're going to need to be able to pick out those terms. You're going to want to be able to graph the linear equation that's in the slope-intercept form. So I'm going to give you an equation. I'm going to ask you to produce a graph. We are also, in terms of our communication vocab, we are going to be able to describe to a partner how we're able to decide between slope and y-intercept. So not only can you locate it, can you tell me why it is where it is? Kind of the what versus how. So to go into the lesson itself, the linear equation, we have a variety of ones that we can use. It's really just going to be any equation that graphs a straight line. So any equation that manages to graph a straight line, we call a linear equation. A good thing to notice is that the first part of it here just says line. It's a line R equation. So it's linear, it makes a line. Now there's a few of them that you might end up seeing. We're going to only look at two of them over the course of this class. Slope-intercept form is the one that we're going to focus on. The equation for slope-intercept form is y equals mx plus b. You might recognize it. It's a pretty popular one people use in their classes. It is made up of two distinct parts. We've got our m and we've got our b. Now, I don't mention the x and y as being the distinct parts because that is really just from a coordinate x comma y. It's any kind of coordinate that uses those letters. The parts that are new for this one are the letters M and the letters B. Now, each one of those is actually in reference to a different part. Slope and intercept is what those letters represent. M is slope, and B is y-intercept. Now, you probably have heard the word slope before. Maybe you haven't had to deal with using slope, but when we talk about slope, you may have heard the slope of a hill, or you may talk about the slope of a roof. I don't know if any of you had to do roofing before, but when your slope of your roof is really steep, it's terrifying. You're holding on for dear life up there. If the slope is really low, not so bad. You can walk across it. I'm still really shaky legged when I get up there. I'm real afraid of heights. But slope is just a measure of the steepness of something. So when we have a line, we may have it going up real sharp like this. We may have it only going out like that. Maybe going down real sharp, down real flat. That's the kind of thing that we're talking about when we mention slope. So really, it's just a measure of, I like to put steepness. Your y-intercept, that one has a different meaning. So each one is going to do its own part. A y-intercept is asking where on the y-axis are you intercepting? Or you can think of it as where are you touching on the y-axis? Touch y-axis. So the way that I like to remember it, the way that I like to do the work is M, I like to think of the word move. When I see B, I like to think begin. So where am I beginning on the y-axis and how am I moving once I've made that first stop? If you think about it in those terms, it makes everything that comes after a little bit easier to work with. So slope intercept form broken down like this. That's how we're going to be using our information. So I'm going to move it on down. Before we actually graph, we're going to come back and we're going to look at how do we just plot points, because that's going to be a useful tool for us to actually make a graph. Normally, I would call out to everybody at this point, like, hey, you do this one, you do this one. It's just me talking to an empty room right now. And in fact, I'm in the dark. You can tell by the video quality. Really depressing, actually. Makes me wonder what I'm doing with my life. But I'm just going to take each of these points, throw them up here. A good way to think, remind ourselves that all coordinates are in the form x comma y. So the first number that's listed is the x. The second number that's listed is the y. So with a coordinate of 4, 3, we need to find a way to represent that visually. The x-axis runs left and right. The y-axis runs up and down. And I have a lot of people get confused because when we start throwing in negatives, it throws people off. The basics of it is that you're always going to put your positive x's on the right side, your negative x's on the left side. In the same way, y is positive up and it is negative down. A good way that I like to think about it is when I'm reading, I read from left to right. So it makes sense that I go from negative to positive. Positive going right because that's the way I'm trying to move normal. Same thing with y going up and down. For me, it makes sense to imagine down is negative because if I'm feeling down, I'm feeling bad. And y is positive going up. Up is a good thing. So you kind of have to find a way to remember it. It gets easier the more you do it. The further away you've been, the harder it's going to look. But just trying to get the practice of it. When we've got the coordinate 4, 3, that means I'm at a positive 4 for x, a positive 3 for y. So I'm going to count 4 in the positive direction for x, which is right. 1, 2, 3, 4. And once I've done that, I'm going to count 3 in the positive direction for y, which is up. So even though plotting points is a relatively simple skill, you just put a dot on a page, there's a lot of thinking that has to go into it. Which way am I going for the x? Which way am I going for the y? And being able to count and do that accurately each time is what we call a fundamental skill. I can't do what I do next until I know how to graph points. So 4, 3. Next, we have -2, -5. Negative for x goes left. Negative for y goes down. So I'm going to go left 2, 1, 2, and then down 5. 1, 2, 3, 4, 5. Lost my spot there. So this one's B. This one's A. Feel free again to pause the video at any time if you want to take a moment to plot these points or if you just need to slow down. C is at 3, -1. So we're going to count right 3. 1, 2, 3. Ooh. Of course, I jumped the gun there. Right 3, and then a -1 for y is down 1. So right there. That's C. D is -4, 2. So count left 4. 1, 2, 3, 4, and then up 2. That is D. E is 6, 0. We're going to count right 6 because it's +6. 1, 2, 3, 4, 5, 6. And a 0 tends to throw people off. but you really just don't move. I don't go up, I don't go down, so it's right there on the axis itself. This is E. F is at 0, 3, so 0, 1, 2, -3. That's F. Notice I did not move left or right, and I went down 3. For G, which is 0, 5, I start at 0 and I go up to 5. 1, 2, 3, 4, 5. For some reason that's green now. H is -3, 0. So I'm going to go left 3, 1, 2, 3, up 0, put a dot. H. And lastly, I is at 0, 0. If I do not move left or right and I do not move up or down, I'm right here, right stab in the middle. That would be I. Forgot to label one up there. Why didn't you say anything? Why didn't you stop me? The only one up here that does not have a label, that should have a label, there's only one up here that has a special name, is at 0, 0. We have a special word for that one. That is called the origin. If you think about it like the origin of a species, it is the beginning. All right, so that is the graphing. Moving on down, the next thing we want to do is be able to locate some terms. It says identify the slope and y-intercept for each of the following. So we're identifying key terms from a linear equation. We've got y equals 2x plus 1. Keep in mind, our equation is y equals mx plus b. So if I want to find slope, well, keep in mind, we just talked about how slope is the same thing as the letter m. So when I'm looking at this, I'm saying, okay, where is my m? I think a good way to keep in mind where to find n is strictly in terms of where in the hell is my x? M is the thing in front of x. So if I look here, the only thing that makes sense for me to label as m is my 2, because that is directly in front of x, similar to how m is in front of x. So I'm going to write m equals 2. Y-intercept, we labeled above as b. Here, it is the thing that is after the x. So here, plus 1, notice how it's not with the x, it's afterwards. That tells me that my b is 1. Now again, this is not the kind of problem that we're going to be facing. This is a core skill, being able to look at an equation and pick out the things that we need for what we're going to do next. The next one, next to the x is the m. So we've got two numbers here. Some people get thrown off. They say 3, or they'll say 4. It's actually both. It's the -3 over 4. That entire fraction is our slope. And then our b value here is the value afterwards. Now, again, be very careful about your negatives. Just like here, there was 2 numbers with a negative. You have to write it all. A -5 is going to be the entirety of b. Not just 5, it's the -5. The last equation there that says y equals 7, that's the one that's the weirdest of the group. What you're allowed to do, if there's ever anything missing entirely, you can think about how many elephants are in the room, how many giraffes are in the room. There's a number that's associated with saying that there isn't any. There's no x here, just like there's no elephant in the room. I have 0 elephants, so this has 0 x's. I can write it as y equals 0x plus 7. At any point in time, you can throw in a 0 for something that's gone. Well, now that I've got my parts, I can label out m is 0 and b equals 7. So that's how you pick out the values of your equation to represent slope and to represent y-intercept. Now we're going to take these skills and we're going to put them together, and we're going to now start producing graphs of linear equations, and those steps are written out here. This is how to graph a linear equation in slope-intercept form. You're going to plot a point on the y-axis measuring your b, which keep in mind is our y-intercept. Step 2, you're going to turn your m, which is slope, into a fraction if it isn't already. So if it's already a fraction, you're good. You don't need to worry about it. But if it isn't yet a fraction, you need to make sure it's a fraction. Step 3, starting at your first point, count up or down by the numerator and right by the denominator to make a new point. As a reminder, for every fraction, since we wrote it as a fraction before, every fraction is really in the form numerator over denominator. Just as a reminder of what those words meant. So the top number is going to tell you up or down. The bottom number is going to have you moving right. Now, there is a circumstance where we're going to move left. Notice how I didn't include a space for going left. The version of this that's full is you're going to take the top number, go up or down. The bottom number, you're going to move right or left. Now, typically speaking, when you're working with a fraction, your bottom number should never really be a negative. That's why it's not very common to move left. The only circumstance you're ever going to move left is when you're moving off of what your graphs can support. And we will see a couple problems that do that. When you are unable to move in the direction you want to do, you kind of have to put it in reverse, Terry. You have to send it back. So a way to think about that is if you want to go up and right, you can go in reverse and go down and left instead. Makes the same action, makes the same line. So let me go over to the next page and have it in the top. You may have to put it in reverse. We've got a couple examples that we can look at here. So graph each of the following. Y equals negative x plus 2. So step 1, plot a point on the y-axis matching our b. So I'm going to rewrite this here. Y equals mx plus b. Our b is 2. And so since our b is 2, we want to make a dot on the y-axis at 2. So here, boom. That step is now done. We've made our first dot. Step number 2, turn your slope into a fraction if it isn't already. Our slope is currently missing its number. You can always throw a 1 in when you're in doubt. So -1 is what I have for my slope, and I like to write those on the side. But that's not a fraction. I need a fraction if I'm actually going to do anything with the slope. So what you can easily do, just like before, when in doubt, throw a 1, I can always divide by 1 as well. Every number could secretly be divided by 1. And with that, now I'm going to build my instructions. The top number is either going to be an up or a down, and the bottom number is going to be a right or a left. So let's see what makes sense. A -1 would be a down. If we're losing, if we have a -1, we are moving down. And a 1 on the bottom is positive. That is right. A good way to think about it, for the top number, if you know you're moving up or down, you can really just decide for yourself, like, wait, where was -1? It was down here, so down. Where was +1 for the x-axis? Well, it's right here, so that's to the right. I kind of use the graph itself as a way to check myself. So we're going to move down 1, right 1, down 1, right 1, down 1, right 1. Now, just like I mentioned earlier, I have enough dots here, but if I wanted to go backwards, if I wanted to go in reverse, instead of going down, I could go up instead of right, I could go left. So I could go up and left, up and left, up and left. If you notice, it still maintains the same line. All I have to do at the end, connect my dots. As you can tell, I'm not a great artist. Kind of swoops a little bit. Do your best. I'll understand. We're done. Next one says y equals -3. That one's a weirdo. If we remember, whenever we're missing something, like there's some stuff that's missing, we could always put a 0. 0x. I guess I shouldn't put plus. It's a -3. So 0x minus 3. Well, now that I have that, I can plot my first point, which is at the B. So the B of -3 would put me 1, 2, 3 here. Keep in mind, pause as you see fit. Give a chance to catch up and or practice, work on it. 0 is what I'm going to have for my slope. So I'm going to write it over here. It's not a fraction. And our step 2 said we need to make a fraction. So let me just throw it over 1. Always allowed. And when I have 0 over 1, I'm now going to write my instructions. 0 isn't up or down, so you could really write whatever one you prefer. I'll just throw up because it's less letters. 1 on the bottom is positive. That is moving right. So 0 up, 1 right. Oh, what did that happen for? 0 up, 1 right. 0 up, 1 right. 0 up, 1 right. And we have enough dots to draw our line. It's a horizontal line. Continuing on. Y equals 5x. Again, this is missing something. It has the x term here, but it doesn't have the plus b that we would expect. And when we are missing our plus b, we can just write plus 0. If you're ever missing something when you're timesing or dividing, you can use a 1. Whenever you're missing something when you're adding and subtracting, you can put a 0. So 5x plus 0, we will start at 0. 5 is what I'll copy on the side, and I can put that as 5 over 1. 5 on the top would be up. 1 on the bottom would be right. So up 5, 1, 2, 3, 4, 5, right 1. 1, 2, 3, 4, 5, right 1. And if I felt like, that's a little hard to see, I could go down 5 and left 1. 1, 2, 3, 4, 5, left 1. Make my line. Next one is where we get a little bit weird. We got some negatives going on here. So if I write in my equation, and that's always a good habit to be in, y equals mx plus b. Our b value is shown as a -2, so we'll start at -2. Our slope, or m, is shown to be a -1/3. Now there's a negative out in front of the fraction. If you ever see something like this, and this does happen, what you're supposed to do is take that negative and apply it to the top. You're allowed to technically, depending on the math class, you're allowed to put it on either top or bottom. It's just a good habit to always put it on the top of the fraction. Mostly because that's what you'll see with all the other textbooks. They're always going to put the negative on the top. I think it's one of those things that there's not really a correct answer. So a bunch of mathematicians got together at one point and they said, okay, for the sake of like everybody using the same thing, just do this. So whenever you see a negative in front of a fraction, the polite thing to do is just to put it on the top of the fraction. So if I copy that over here, that's a -1 over 3. Now with a -1, I would be moving down because that is negative. 3 is positive. So that is right. And that's kind of why I said that we don't need to worry about negatives on, or we don't need to worry about moving left. Because if I never put the negative on the bottom, I would never be moving left. Some people ask, like, well, what if there's a negative on top and bottom? Well, I would argue that if you have a negative on top and bottom of your fraction, really you've got a double negative, which is just positive. So it's kind of one of those like self-defeating kind of things. But anyway, if we go down one and right three, down one and right three, down one and right three, erasing my mistake. Down one and right three. I can also go up one and left three, make another dot, switching on me. I can draw my line, and then I'm done with that. Moving on down to the last two examples. I've got y equals 4x plus 6 and y equals 1/2 x minus 4. I'd recommend yet again pausing so that way you can try these for yourself before I show the answer. If we're working with 4x plus 6, our b value is 6. So we're going to start up here at 6. 1, 2, 3, 4, 5, 6. And our slope here in front of the x is 4. And if I copy that on the side, I have my 4. That is missing its fraction, so I can always throw a divide by 1. And from there, I'm going to label what directions to go. With a positive 4 on top, that is going to be 4 up. With a positive 1 on bottom, that is going to be 1 right. So with me labeling it 4 up and 1 right, I want to go 1, 2, 3, 4, and man, that's really dangerous, kind of close to the edge of the graph. You guys might have started this and then said like, but I only have 2 dots. Well, this is a situation where we would kind of have to put it in reverse if we want to get anything more useful. Instead of going up 4 and right 1, I could go down 4, 2, 3, 4, and left 1 to make a dot. And I could keep going in reverse like that to keep making more dots. You might find in the assignment that you can't even make a second dot at all, and you're forced to go in reverse. It's not something that has like a perfect answer. You're going to try to do it as best you can, and if you have to put it in reverse, go in reverse. So let me draw my line. I have that one done. The last problem here says 1/2 x minus 4. I've got an intercept of -4. 1, 2, 3, 4. Again, switching my color. My slope is 1/2. I don't need to make that 1 over 1 because it's already a fraction. I have 1 on top, so that is 1 up. 2 on the bottom, that is 2 right. So up 1, right 2. Up 1, right 2. Up 1, right 2. Alternatively, I can go down 1, left 2, down 1, left 2. All right. Hope this helps. Stay safe.